A truck rolls onto a scale carrying what looks like one thing: junk, bent steel, copper wire, pieces of aluminum, dirty hardware, maybe sections of an old structure, maybe material stripped out during a renovation, maybe leftovers from a fabrication shop. To the person who brought it in, the important fact is that it is unwanted. To the person who owns the scrapyard, almost nothing about that load is simple. Some of the metal may be worth much more than the rest. Some may need to be cut, separated, cleaned, or compacted before a buyer wants it. Some may be expensive to move. Some may carry fluids, batteries, refrigerants, or other problems that change how it can be handled. And every piece of saleable metal is connected to a market price the yard does not control. Before the truck is unloaded, the operator has to answer two questions. What is actually in this truck, and what is it worth today? That second question sounds like the money question. It is not. Because a scrapyard does not make money simply because metal has value. It makes money only if it can buy that value correctly, identify it correctly, improve it economically, move it cheaply enough, comply with the rules around it, and sell it to the right downstream buyer before too much of the spread disappears. That is the strange contradiction at the center of this business. The value is visible, the margin is hidden, and a yard can be surrounded by valuable metal while quietly becoming a terrible business. Start with the supply side, because a scrapyard without incoming material is just an expensive piece of industrial real estate. In the United States, scrap can enter the recycling system from very different places. Large recyclers describe industrial manufacturing and fabrication shops as sources of new or prompt scrap. Older material can arrive through dealers, demolition work, auto-related businesses, commercial sources, and members of the public. Non-ferrous material can come from manufacturers and specialized industries, as well as independent dealers and retail customers. Those sources do not behave like one unified supplier. A factory producing clean, predictable offcuts is different from a demolition contractor arriving with mixed material. A dealer bringing a known grade is different from a homeowner cleaning out a property. A steady commercial account is different from a one-time retail seller. And even the phrase, "who pays whom," has no single answer that should be forced across all of those relationships. The verified evidence used here is strongest on purchased scrap economics. Recyclers compete for raw material partly through the price they offer. Commercial collection and removal arrangements can vary, and this research does not establish one nationwide rule saying the recycler always pays the supplier always pays for removal, or pickup is always free. That limitation is useful because it reveals the real owner question. Whatever the commercial arrangement, the operator has to know the net economics of getting the material through the gate. If the yard is purchasing the scrap, the offered price has to leave room for downstream value, processing, and transport. If a service component exists in a particular commercial relationship, the owner still has to evaluate the metal and the work together, rather than pretending the material and the logistics are separate businesses. For the owner, the first competitive problem is therefore not processing. It is procurement. Steel Dynamics, one of the large U.S. companies with a metals recycling operation, describes two major factors in competing for raw scrap: the price offered and the proximity of the processing facility to the source. Those two factors can pull in opposite directions. Imagine two yards that both want the same industrial scrap stream. One is closer. The other is farther away, but is willing to offer a more aggressive purchase price. The farther yard may win the material, but its transportation burden is larger. The closer yard may be able to offer less and still produce similar net economics because the material costs less to move. That does not produce a universal formula. It produces a discipline. The owner cannot evaluate purchase price without geography. Offer too little, and material can go somewhere else. Offer too much, and the yard can win the load while losing the economics. Be too far away, and transportation can consume part of the advantage before the material even reaches the scale. So location is not simply where the yard happens to sit. It influences what supply is realistically available and what the operator can afford to pay for it. That matters because the American scrap recycling market is not one giant centralized system. Steel Dynamics describes the domestic industry as highly fragmented, with small, regional, national, and global companies competing inside the same broad material stream. For a local operator, that fragmentation can make the market feel intensely local, even though the finished commodity may ultimately move into national or international markets. A contractor does not need to care about the global path of the metal. The contractor needs to know who will take the load, how far away that recycler is, how the material will be graded, and what the transaction is worth. The scrap operator lives between two worlds. Upstream, supply is local, physical, irregular, and relationship-driven. Downstream, the material is being prepared for buyers who want defined grades and usable specifications. The yard exists in the middle because somebody has to convert one into the other. That creates a subtle form of inventory competition. A recycler is not merely waiting for discarded metal to appear. The yard needs enough suitable feedstock to keep labor, space, trucks, and processing capacity productive. But chasing volume too aggressively can destroy the spread before the material arrives. That makes procurement a balancing act. The owner wants material, but not at any price. The owner wants recurring suppliers, but not if the route is uneconomic. The owner wants volume, but only volume that can eventually become saleable inventory. And the moment a truck crosses the scale, the operator stops competing for supply and starts taking inventory risk. Because the yard does not really buy metal, it buys grades, recovery possibilities, processing work, transportation obligations, and future sale value disguised as a pile of objects. Imagine two trucks arriving with exactly the same total weight. If this were a business where weight alone determined value, the economics would be easy. Put the truck on the scale, subtract the empty weight, multiply by a price, and you would have a clean answer. Scrap does not work that way. Steel Dynamics says processed scrap pricing can depend on market demand, material composition, size, weight, quality, grade, location, and transportation cost. That list is the reason 1 ton of metal is not economically equivalent to another ton of metal. The broadest distinction is between ferrous and non-ferrous material. Ferrous scrap is built around iron and steel. Non-ferrous material includes categories such as copper and aluminum, along with other metals and alloys. But even those labels are only the beginning. The operator has to understand exactly what a downstream buyer will accept. Material can differ by composition, cleanliness, dimensions, attachments, coatings, insulation, and contamination. A mixed load may contain several things that look similar to an inexperienced seller but belong in different commercial grades. That is why specifications matter. The Recycled Materials Association publishes specifications used as industry guidelines for buying and selling processed scrap commodities. Those specifications can define what a grade is supposed to contain and what kinds of contamination or unwanted material can make a shipment less acceptable. For the owner, grading is not trivia. It is purchasing discipline. Suppose a load appears to contain a valuable non-ferrous component. The buyer sees enough of that material to justify an aggressive offer. After unloading and sorting, the yard discovers that more of the apparent value is tied up in attachments, insulation, mixed grades, or unwanted material than expected. The physical load has not become worse after purchase. The yard's understanding of it has become more accurate. And that new understanding can reveal that the purchase price was too high. The mistake was made before any expensive machine touched the material. This is one of the reasons scrap businesses rely on people who can recognize material quickly and make judgments under pressure. The scale operator, buyer, sorter, or yard manager is not simply naming metals. That person is estimating what portion of the load can become a saleable grade and what it will cost to get there. The same weight can carry very different amounts of recoverable value. A piece of insulated wire is not the same commercial product as clean copper. Mixed aluminum is not automatically the same as a tightly specified aluminum grade. Steel that requires more handling or size reduction is not economically identical to material that can be shipped with minimal processing. Contamination adds another dimension. It can reduce what a downstream buyer is willing to pay. It can create additional handling. It can change whether the material meets a specification. In some cases, it can bring environmental or safety obligations that change whether the yard wants the load at all. The operator therefore thinks in layers. First, what material is present? Second, what grade can it become? Third, what work is required to get there? Fourth, where can that grade be sold? Fifth, what will it cost to move it? Only after those questions can weight become meaningful. This is why an experienced yard can look almost suspiciously picky to someone who sees only a pile of metal. The yard is not rejecting value, it is separating theoretical value from recoverable commercial value. The customer may see a heavy object and assume heaviness means money. The operator sees something else, a future shipment that either meets a buyer's requirements or does not. So when a seller asks, "How much is this metal worth?" the operator is really answering a more complicated question. What can this become? That distinction is crucial. The scrapyard is not purchasing the object for what it was. It is purchasing recoverable material based on what it can be turned into and who will buy that output. The better the operator understands that future sale, the more accurately the operator can value the incoming load. Which brings us back to the scale ticket. Because once the yard puts a purchase price on that load, the business stops being a sorting puzzle and becomes a financial commitment. A customer may think the scale tells the yard how much metal arrived. For the operator, the scale also tells the yard how much exposure it is about to take on. The basic commercial idea is a spread. A recycler buys scrap, processes or prepares it, and later sells processed material into a downstream market. Large recyclers explicitly track the difference between what processed metal sells for and what purchased scrap cost. But that spread is not profit. It still has to absorb processing, labor, equipment, shipping, maintenance, compliance, losses, and the cost of holding inventory. So the buying price is one of the most important decisions in the business. Think about the transaction backward. The downstream buyer has a specification and a market price for a particular grade. The scrapyard is standing at the other end of the chain looking at an inconsistent incoming load. Between those 2 points are all of the things the yard must do correctly. It must identify the material. It must decide how much of the load belongs in each grade. It must determine whether processing adds enough value to justify its cost. It must handle and store the material. It must build a shipment that the next buyer will accept. It must move that shipment to a buyer whose net price makes sense after transportation. And it must do all of that while market conditions can change. The purchase price is what remains after the operator mentally reserves room for those steps. Suppose the yard identifies a load correctly, but pays as if nothing will go wrong. There is no allowance for additional processing, no room for freight to rise, no room for a downgrade, no room for a market move. That can produce an impressive buying program and a fragile business. The operator may win more material than competitors because the yard pays aggressively. Trucks keep arriving, the scale stays busy. Inventory grows. From the road, the yard looks successful. But if the purchase price absorbed most of the future sale value, the yard may be accumulating revenue without accumulating profit. This is why there is no useful universal answer to the question, how much profit does a scrapyard make per ton? The sources do not support one. Different materials have different values. Different grades require different processing. Transportation changes by geography. Market conditions move. Facilities have different equipment and labor structures. Some yards aggregate and resell. Others process deeply. Some are connected to mills. Others depend on external buyers. A single profit per ton number would hide the part of the business that actually matters. The same is true of a universal margin percentage. A small independent yard, a major shredder, a broker, and a vertically integrated recycler are not interchangeable businesses just because they all touch scrap metal. The useful unit economic question is not, what is the normal profit on a ton? It is, what value is this specific operator adding between purchase and sale, and what does that value cost to create? The scale ticket records a bet on that answer. The yard gives up cash or creates a payable obligation because it believes the material can later be sold for enough to cover every step in between. A good operator tries to leave room for reality. A bad purchase can be surprisingly hard to fix downstream. You can sort material better, you can process it more efficiently, you can negotiate transportation, you can search for another buyer. But if you fundamentally overpaid for what came through the gate, every later department is trying to recover a mistake already embedded in inventory. That is why the value can be visible and the margin still hidden. The pile may look rich in metal. The owner has to know how much of that apparent value is already spoken for by the cost of buying, preparing, and moving it. Preparation is where the business becomes visually dramatic. It is also where people most easily confuse activity with value creation. Magnets lift steel. Shears cut oversized pieces. Balers compress material. Shredders tear complex objects apart. Sorting systems separate streams. Loaders move piles that would be impossible to handle by hand. Those machines are spectacular. But from the owner's perspective, none of them matter because they are spectacular. They matter only if they solve a commercial problem. Large recyclers describe processing methods that include sorting, shredding, shearing, cutting, baling, and breaking. The goal is not simply to make the material smaller. The goal is to turn incoming scrap into forms and grades that downstream buyers can use. Sorting can separate higher value material from lower value material instead of selling everything as a mixed stream. Cutting or shearing can reduce oversized scrap to dimensions a buyer can handle. Baling can make certain materials denser and more efficient to handle or transport. Shredding can break complex scrap into smaller fractions that can then be separated further. Every one of those steps has a cost. Not an abstract cost, a specific operating burden. A loader has to move the material into position. A person or system has to separate grades. A machine consumes energy and wears as it works. Maintenance has to happen. Finished material has to be moved again. Space is occupied while one stage waits for another. The owner is therefore asking a disciplined question before processing anything more than necessary. Does this step improve the saleable value by more than it costs us to perform it? That is a very different question from, can we process this? Imagine a pile that can be sold now as a lower-grade mixed material. The yard also has the capability to separate it into cleaner grades. If the cleaner grades command enough additional value to pay for the extra handling and processing, separation makes sense. But if the additional value is small and the work is expensive, the visually impressive process can reduce the economics. The same logic applies to size reduction. A buyer may require material to fit a certain commercial specification. Cutting or shearing can make the shipment acceptable. In that case, the machine is solving a sales problem. But cutting material that already meets the next buyer's needs merely because the yard owns a shear is not value creation. It is activity. That distinction is one of the quiet advantages of a disciplined operator. The yard does not try to maximize processing. It tries to maximize profitable transformation. The commercial target is the buyer's specification. If a downstream consumer pays more for a cleaner, more uniform grade, separation can create value. If a buyer requires material within certain dimensions, size reduction can create value. If transportation is a major part of the economics, increasing density may improve a shipment. But processing for its own sake is expense. That is why the business models separate by scale. A smaller local yard may make money by buying, identifying, sorting, accumulating, and shipping material to a larger processor. It does not need to perform every transformation itself. A processor with more equipment may buy material that needs additional preparation and capture more value by turning it into marketable grades. A large shredding operation takes on still more complexity, including major equipment, throughput requirements, environmental controls, safety risks, and downstream separation. And then there are brokers, mills, foundries, smelters, refiners, and manufacturers further along the chain. The important point is that a scrapyard does not become a better business merely by moving farther downstream. Every additional function creates another capability and another cost structure. A smaller yard can effectively let another company own the expensive next processing step by selling material into that processor's feedstock stream. The local yard earns its part of the chain by aggregation, grading, basic preparation, and logistics. The processor earns another part by investing in equipment and throughput that change the material further. The downstream mill or foundry earns value by consuming the processed scrap as raw material for production. No single operator has to own the entire chain. That is why more vertical and more profitable are not synonyms. The economic question is always the same. Where in the chain can this operator add value efficiently? That keeps the machines in their proper role. They are not the protagonist. They are tools that convert one commercial condition into another. Once the owner sees equipment that way, a new risk becomes obvious. The more processing capability a facility owns, the more important throughput, reliability, safety, and downstream demand become. A scrap business can look very different depending on where you stand inside it. At one end, a smaller yard may need accurate scales, material handling equipment, storage areas, trucks or containers, and people who know how to grade and organize inventory. At the other end, a large processor may operate cranes, shears, balers, shredders, conveyors, sorting systems, and heavy fleets. It is tempting to think of that progression as an upgrade path. More machines, more processing, more profit. But the sources do not justify that assumption. A machine creates economic value only when enough suitable material passes through it, when the output has a reliable market, and when the operating cost does not consume the value improvement. Consider a hypothetical shredder with insufficient feedstock. The machine may be capable of producing a useful processed stream. The facility may have invested heavily in the surrounding yard, material handling, maintenance, controls, and labor. But capability is not the same as utilization. If too little material reaches the machine, the cost base does not disappear simply because production is slow. Now reverse the problem. Suppose feedstock is abundant, but the downstream market for the output is weak or expensive to reach. The facility can process enormous volume and still create a bottleneck at the selling end. Processing capacity only matters when supply, operation, and demand line up. That is why scale creates both advantage and obligation. Larger equipment can unlock processing options a small yard does not have. It can create throughput, density, separation, and access to different downstream products. But scale also means more things have to go right at once. Equipment has to run, employees have to operate it safely, material has to arrive in sufficient quantity and suitable form, finished grades need buyers, and the price spread has to support the whole system. Heavy industrial equipment also changes the labor problem. OSHA's scrap recycling guidance identifies hazards involving forklifts, moving machinery, unexpected equipment startup, toxic metals, manual material handling, combustible dust, fire, and explosion. For the owner, safety is not a separate moral paragraph pasted onto the business model. It affects who can operate equipment, how procedures are designed, how maintenance is performed, how downtime is managed, and what happens when an incident interrupts production. Skill matters because the equipment is handling irregular material, not identical products moving through a clean assembly line. A loader operator may be moving heavy, unstable pieces. A sorter may be making rapid grade decisions. A mechanic may be responsible for equipment exposed to abrasive material and difficult operating conditions. A buyer may commit working capital based on material quality and market conditions. Different facilities, therefore, have different economic centers of gravity. For a small yard, the advantage may be local relationships, grading skill, fast inventory turns, and a simpler cost structure. For a processor, the advantage may be throughput and the ability to produce grades that command stronger downstream demand. For a large shredder, scale can create access to complex scrap streams and advanced recovery, but scale also raises the penalty for weak utilization, maintenance problems, or insufficient feedstock. There is no single correct equipment stack because there is no single scrapyard business model. The owner should not ask, what machines does a scrapyard have? The better question is, what economic problem does each machine solve at this facility? A scale solves measurement. Material handling equipment solves movement. Sorting solves grade separation. A shear can solve size. A baler can solve density and handling for suitable material. A shredder can solve a complex liberation and size reduction problem for certain feedstocks. Each answer creates a second question. Is that problem large and frequent enough here to justify owning the solution? That question protects the business from a dangerous illusion. It is possible to own equipment capable of producing a valuable commodity and still lose money producing it, because the machine cannot control the market price, and the market price can move while the metal is sitting in the yard. This is where scrap starts behaving less like a local service business and more like a commodity business. The yard may buy material today and sell it later. That gap creates working capital risk. Cash goes out when inventory comes in. Cash comes back after the material has been processed, sold, shipped, and paid for under whatever terms apply to that transaction. While the inventory sits, the market can change. Radius Recycling described this risk explicitly in its public filings before the company was acquired in 2025. The company tracked metal spread, including the difference between selling prices and the purchase cost of scrap, along with processing and shipping expense. It also warned about a painful timing problem. If selling prices fall faster than the recycler can reduce the prices it pays for incoming scrap, the spread compresses. In other words, yesterday's purchase can become today's expensive inventory. Picture the owner's problem. A buyer sets purchase prices based partly on the downstream market the yard can see today. Trucks arrive. The yard pays for material. Inventory starts accumulating while it is sorted, processed, consolidated, and prepared for shipment. Then the downstream market weakens. The operator can lower tomorrow's purchase offers, but yesterday's inventory is already in the yard at yesterday's cost. That is the asymmetry. The selling market can move immediately. The cost embedded in existing inventory cannot be renegotiated backward. At Radius's scale, sales arrangements could add another timing layer. The company reported that sales contracts were generally negotiated with orders placed roughly 30 to 60 days ahead of shipment. That is not a rule for every scrapyard. It is a large company example of the broader issue. Price agreement, physical inventory, processing, and shipment do not necessarily happen at the same moment. Time matters. Radius also reported inventory changes tied to the timing of purchases, sales, and shipment delays, and said borrowings were used in part to support working capital needs and capital spending. Again, the point is not to map a public company's balance sheet onto a neighborhood yard. The point is that inventory is not a pile of free money. It is capital sitting outside. That changes how the owner should feel about a yard that looks full. A full yard can mean strong supply and healthy throughput, or it can mean material is not moving. Those are opposite stories with almost the same photograph. If inventory is turning, the yard is converting purchases into saleable shipments and bringing cash back through the business. If inventory is stuck, capital remains tied up while the operator continues paying labor, equipment, transportation, and other costs around it. The market can weaken during that delay. A buyer can change demand. A shipment can be postponed. A grade problem can emerge. Equipment can fail and interrupt processing. The operator, therefore, has to think about speed without confusing speed with recklessness. Turning material faster does not guarantee a good margin. Selling too quickly into a poor transaction is not discipline. But slow inventory keeps cash tied up and leaves the operator exposed to market movement for longer. That creates a tension between lot size and time. The yard may need to accumulate enough material to build an efficient shipment or keep a process productive. But every additional day of accumulation extends the period in which capital and market risk remain inside the pile. The owner wants enough inventory to operate efficiently. The owner does not want to become a warehouse for speculative metal simply because prices might improve later. The yard is not paid to admire inventory. It is paid to convert and move it. Large public recyclers even evaluate inventory against expected selling values because a falling market can reduce the economic value of material before it is sold. For a smaller operator, the accounting treatment may differ, but the operating reality is easy to understand. If you paid too much for a pile and the market falls, the pile does not care what you paid. The buyer downstream cares about today's market and today's specification. This changes how a disciplined operator thinks about volume. More tons can produce more revenue, but more tons purchased at the wrong spread can also produce a larger problem. The dangerous version of growth in this business is growth that makes the yard busier faster than it makes the economics better. More trucks arrive, more equipment hours are logged, more inventory accumulates, more revenue may eventually be recorded. But if the buying spread is weak, the inventory turns slowly, or freight and processing consume too much of the value, the company has simply scaled its exposure. And even when the market cooperates, the yard has another enemy that gets heavier with every ton: distance. Scrap metal has an annoying property for anyone trying to make money moving it. It is heavy. That sounds obvious until you realize how many business decisions follow from it. Steel Dynamics says proximity to the source of raw scrap is a major competitive factor in procurement. The same company says transportation cost and availability matter when processed scrap is sold. Radius Recycling also identified transportation among the factors that can affect metal spread. So, geography reaches into both sides of the transaction. First, the yard has to get material in. If a commercial customer is far away, pickup becomes more expensive. A truck has to travel out, load or wait, return, and do it often enough to justify the route. Containers may have to be placed and retrieved. Driver time, equipment time, fuel, and unproductive travel become part of the procurement problem. Then the yard has to get processed material out. The downstream mill, foundry, smelter, processor, or other buyer may be in a completely different direction. If the best-paying buyer is far enough away, a nominally higher selling price can be less attractive after freight. That is why the highest quoted price is not always the best economic destination. The owner cares about net value after movement. Imagine two buyers for the same grade. Buyer A offers more, but is much farther away. Buyer B offers less, but is easier to reach. There is no universal answer about which one is better, because freight, shipment size, equipment, timing, and route conditions vary. But the owner's comparison is not price versus price. It is net transaction versus net transaction. Now apply the same logic upstream. A distant source may offer a large amount of scrap. The material looks attractive because volume can improve throughput. But if the route consumes too much time and transport cost, the volume can become a burden rather than an advantage. This is why route density matters as an operating concept even when there is no single correct radius. A truck spending more of its time carrying valuable material and less of its time traveling unproductively supports different economics from a truck running long distances for marginal loads. A low-value, bulky, or contaminated load can be especially punishing because the yard may spend money moving weight that contributes little to saleable output. Density also matters operationally. Some processing steps can make material easier to handle or transport efficiently. But that processing itself has a cost, so the owner again has to compare value created with expense incurred. There is no universal maximum hauling radius that makes sense for every material. A high-value non-ferrous grade can tolerate different transportation economics from lower-value ferrous material. A dense, clean shipment can behave differently from an irregular load that wastes capacity. Local freight rates, buyer locations, equipment, and market conditions all matter. The key idea is simpler. Theoretical commodity value is not the same as economically reachable value. A pile may be worth something on paper and still be unattractive to a particular yard because it is too far away, too expensive to handle, too difficult to consolidate, or too far from the next buyer. This is why a good scrap location connects two maps at once. The first map is supply. Where are the factories, contractors, demolition jobs, dealers, commercial accounts, and retail sellers that can feed the yard? The second map is demand. Where are the processors, mills, foundries, smelters, refiners, or other consumers that can take the output? The yard sits between those maps and tries to minimize the friction in both directions. A facility trapped between weak supply and distant buyers can have impressive equipment and poor economics. A facility positioned close to suitable feedstock and practical outlets can create an advantage before it processes anything. Geography also shapes competition in ways that headline commodity prices do not show. Two yards can look at the same national market and face different local economics because one has a nearby mill, a stronger cluster of industrial suppliers, better transport options, or shorter inbound routes. That is why a commodity business can still be intensely local. But transportation is only one cost that arrives with the material. Some loads bring rules with them, and those rules can change what the yard is willing to accept in the first place. A legitimate scrapyard cannot treat every object as nothing more than recoverable metal. Some objects arrive with liquids, some contain refrigerants, some contain batteries, some can create fire, explosion, pollution, or worker safety problems if they are accepted or processed incorrectly. This is where regulation stops being an abstract compliance department and becomes an operating system. Start with something as ordinary as rain. The Environmental Protection Agency treats scrap recycling facilities as part of Sector N for industrial stormwater. Outdoor storage, loading and unloading, processing, equipment maintenance, and related activities can expose pollutants to stormwater depending on how the facility operates and what permitting rules apply. The practical response is not merely paperwork. EPA guidance describes controls such as housekeeping, spill prevention and response, inspections, employee training, containment, proper fluid management, and maintenance of best management practices. For the owner, each of those words has a physical meaning. Housekeeping means material and residues cannot simply be ignored because they are outside. Spill response means employees need procedures and equipment ready before something happens. Inspection means somebody has to look, document, and correct. Training means workers need to understand the controls rather than treating them as a binder in an office. Fluid management influences how vehicles, equipment, and incoming material are handled. The economic effect is not one mysterious regulatory cost. It is recurring work embedded in normal operations. That is a better way to understand compliance in scrap. Rules alter the process. The altered process changes labor, equipment, space, timing, or risk. Those changes affect the economics of accepting and processing material. For shredding facilities, the intake problem becomes even more serious because a shredder does not care about the history of an object once that object enters the machine. EPA's Best Practices document for metal shredding describes acceptance policies, incoming scrap inspection, rejection of certain material, and depollution of gases, liquids, and solids before shredding. The logic is operational. A facility wants valuable metal to enter the process. It does not want a dangerous or contaminating component to enter with it. That creates an intake gate before the physical machine. Someone has to know what is acceptable. Someone has to inspect incoming material. Some items may need depollution. Some may need to be rejected. Those controls can prevent a valuable feedstock stream from becoming a fire, explosion, malfunction, or emissions problem. This matters because a scrapyard can lose money by accepting the wrong material even when the metal content itself is valuable. The decision is not simply metal equals inventory. The decision is, can this material legally and safely become our inventory under the processes we operate? Consider old refrigeration or air conditioning equipment. Under federal refrigerant rules, when equipment enters the waste stream with refrigerant charge still intact, the final disposer can include a scrap metal recycler. The final disposer is responsible for ensuring that refrigerant has been recovered. When the recycler accepts appliances that were already evacuated, the rules include verification mechanisms, such as signed statements or qualifying supplier contracts. The economic consequence is straightforward. An appliance containing recoverable metal is not simply a metal object. It can also carry a compliance step that has to be completed and documented. For an operator evaluating a stream of appliances, the metal value and the handling obligation belong in the same calculation. Batteries create another example. EPA states that end-of-life lithium batteries are specifically not included in the federal scrap metal exclusion. Many can be managed under universal waste rules, and states can impose more stringent requirements. Again, the owner sees two things at once. There may be commodity value in the surrounding equipment. There may also be a material inside that equipment that cannot simply be tossed into the scrap pile and forgotten. These rules change purchasing and acceptance behavior. A yard may reject certain inputs. It may require preparation before acceptance. It may segregate material. It may need trained employees, designated storage, records, inspections, or specialized downstream handling. The best way to understand scrap regulation is not to ask, how much bureaucracy does a yard face? Ask a more useful question. What does this rule force the operator to do differently with the material? That answer is where regulation becomes economics. There is another reason compliance belongs in the owner's story. A yard that ignores controls may appear cheaper in the short run because it is not paying for the same procedures, training, maintenance, or handling. But a legitimate operator cannot build a durable economic model by pretending those requirements do not exist. So compliance becomes part of competitive discipline. The owner has to price the work that legal operation requires. Environmental rules are only part of the story. A yard may also need to document who brought the material in and what exactly changed hands. Scrap has a theft problem in the public imagination, but turning this into a crime story would miss the business lesson. The useful question is, what legitimate operators have to do because questionable material can enter the market? The answer can include transaction records and seller identification, with details varying by state and locality. Florida provides one concrete state-specific example. Its law for secondary metals recyclers requires transaction records that can include information about the seller, the material, its weight, the consideration paid, and statements related to ownership. That does not mean every state uses Florida's exact system. It means the origin of the material can become an operational fact the yard has to document. For the owner, that creates another layer of intake work. The yard already has to know what the material is. Now it may also need to know who brought it, what records belong with it, and whether the transaction can be defended later. Imagine the scale as the place where three records meet. There is the physical record, what weight came in. There is the commercial record, how the material was graded and valued. And there may be an identity or ownership record required by the applicable rules. If those records disagree, the operator has a problem that has nothing to do with whether the metal can be melted. Documentation also matters when there are grading disputes, ownership questions, or disagreements over what was delivered and how it was valued. A disciplined operation wants the intake process to create a clear trail from seller to scale ticket to material category. That record-keeping costs time and systems, but the alternative is ambiguity inside a business where small classification errors can move money quickly. This is another example of how the scrap operator earns a spread by solving inconvenient problems other businesses do not want to solve. The seller wants unwanted metal handled and a defensible transaction. The downstream buyer wants a defined, usable commodity grade. Between those two ends, the yard has to identify, document, aggregate, prepare, and stand behind the material it sells. And even after every load is documented, clean enough, correctly graded, and safely handled, the yard still has not completed the business model. Somebody downstream has to buy it. A common mistake is to imagine scrap recycling as one business that starts with a junk pile and ends with new steel. In reality, several different businesses can exist along that path. A local yard may aggregate material from many small sources, separate grades, perform basic processing, and build enough volume for efficient shipment. A larger processor may shear, bale, shred, or perform more advanced separation. A broker can arrange sales between suppliers and consumers without owning every physical step. Downstream, ferrous scrap can move to steel mills and foundries. Non-ferrous grades can move to smelters, refiners, alloy producers, specialty mills, wire and cable producers, and other manufacturers. The business model changes depending on where an operator stops. A local yard does not need to become a steel mill to create value. Its job may be finished when it can deliver a predictable grade in useful volume to the next processor or consumer. That distinction matters because downstream access can become a concentration risk. A yard may operate in a fragmented recycling industry and still have only a limited number of economically realistic buyers for a particular grade because transportation is expensive. Theoretically, a buyer farther away may pay more. Practically, freight can make that buyer irrelevant. So the operator's real market is defined by both price and geography. That means buyer relationships are not merely sales relationships. They influence what the yard is willing to buy upstream. If a recycler knows there is dependable demand for a certain grade, it can evaluate incoming material with a clearer path to sale. If the downstream outlet becomes uncertain, the same incoming material can become riskier, even though its physical composition has not changed. This is one of the strange features of scrap inventory. Its value depends partly on what it is and partly on who can realistically take it next. Large vertically integrated companies can look very different. Steel Dynamics reported that in 2025, about 65% of the ferrous recycling volume from its recycling operations was shipped to its own steel mills. That is not a structure available to an independent neighborhood yard. But it illustrates the strategic value of having a dependable downstream outlet. A vertically integrated recycler can feed affiliated mills. An independent yard has to earn and maintain external buyer relationships. Those relationships matter when markets become difficult. A downstream buyer may have strict specifications. It may adjust purchasing volumes. It may favor certain grades. Transportation availability may change. Export conditions can change. Domestic demand can change. The yard cannot control those forces. It can control whether its material consistently meets expectations and whether it has more than one practical route to market where possible. This is one form of concentration risk. If a yard depends heavily on a small number of downstream outlets, those buyers can become critical to inventory movement. There is a mirror image upstream. If the yard depends heavily on a small number of suppliers, losing one stream can reduce throughput and leave equipment or labor underused. The owner is therefore managing concentration on both sides of the scale. Too little supply, and the yard may lack volume. too few buyers, and the yard may lack negotiating power or a practical exit for certain grades. A strong position is not necessarily maximum diversification at any cost. It is understanding where the business is exposed and avoiding the illusion that a pile has value simply because a commodity benchmark exists somewhere in the world. The actual value to this yard depends on the chain it can reach. That brings us to the real skill in scrap recycling. The owner cannot make copper more valuable by wishing. The owner cannot command steel prices upward. The owner cannot make a distant mill move closer. So what can a good operator actually do better? The strongest scrap operator is not the person who predicts every commodity move. It is the person who builds a business that does not require perfect predictions to survive. Start with buying discipline. The operator has to know material well enough to avoid paying for value that is not really there. Grade, quality, contamination, size, and transportation all affect what the material can become and what it can sell for. That means a good buyer is not simply aggressive. A good buyer is accurate. Accuracy matters twice. First, the buyer has to classify the incoming material correctly. Second, the buyer has to connect that classification to a realistic downstream transaction. A technically correct metal identification can still lead to a bad purchase if the yard misjudges processing, transport, or buyer demand. Then comes processing discipline. Every cut, sort, bale, shred, and movement should have an economic reason. If a process changes the material into a better commercial grade, improves shipping efficiency, or unlocks a stronger downstream market, it may be worth doing. If it merely adds handling because the machine happens to be available, it can destroy value. Then there is throughput. Equipment and labor become more useful when the facility has enough suitable material moving through the right process. But volume for its own sake is dangerous. More incoming tons purchased at a weak spread only scale the mistake. A disciplined owner therefore separates two questions that inexperienced operators can confuse. Can we handle more volume? And should we buy more volume at these economics? Those are not the same question. Inventory turnover connects them. The faster the yard can convert purchased material into saleable inventory and move it downstream, the less time capital sits exposed to price changes and operational surprises. But fast turnover only helps when the underlying transaction is sound. The goal is not motion for its own sake. The goal is efficient conversion of working capital back into cash. Logistics discipline matters too. The best source is not necessarily the source offering the most metal. It may be the source whose material is close enough, predictable enough, and valuable enough to justify the route. The best buyer is not necessarily the buyer quoting the highest headline price. It may be the buyer whose net price after freight, specification risk, and reliability produces the better result. Compliance discipline protects the same economics. Stormwater controls, fluid handling, battery management, refrigerant verification, safe equipment procedures, and transaction records may look like costs that do not generate revenue, but they are part of the process required to operate legitimately and to keep bad inputs from becoming larger operational problems. And then there is market discipline. The owner has to understand spread, not just price. Steel Dynamics provides a useful large company illustration. In 2025, it reported that its ferrous recycling metal spread was roughly flat from the prior year, while non-ferrous metal spread increased by 24%. The company said the combination of volume and spread changes helped metals recycling operating income rise by 27% to $97.2 million. That is not a normal yard margin and should not be treated as one. It demonstrates a narrower point. Mix and spread matter independently of headline commodity prices. A yard can sell into a high-price market and still struggle if it paid too much for feedstock or incurred too much processing and freight cost. It can operate in a weaker market and still perform better than a competitor if it buys more carefully, turns inventory faster, processes selectively, and protects its downstream relationships. The owner is continuously balancing several clocks. There is the supply clock. Can enough suitable material be acquired at a rational cost? There is the processing clock. Can the facility convert material without creating bottlenecks or unnecessary handling? There is the equipment clock. Are machines available and utilized enough to justify their role? There is the inventory clock. How long is cash tied up before sale? There is the logistics clock. How quickly and economically can material move in and out? And there is the market clock. What happens to price while all of that is taking place? The business does not need every clock to be perfect. It needs them to be aligned well enough that one weakness does not consume the entire spread. That is why the best operating advantage can be boring from the outside. Accurate buying, consistent grading, selective processing, reliable equipment, fast enough inventory turns, reasonable routes, clean documentation, practical buyers. None of those produces the visual drama of a giant shredder. Together, they decide whether the shredder is part of a business or merely part of a spectacle. Now return to the truck from the beginning. The metal inside already had value before it reached the yard. That is important because it tells us what the scrap operator is not being paid for. The operator is not being paid for discovering that metal is valuable. Everybody in the chain already knows that. The operator is being paid for solving all the reasons that value is difficult to capture. The material is scattered across factories, demolition sites, commercial accounts, dealers, vehicles, equipment, and individual sellers. So the yard aggregates it. The material arrives mixed, irregular, attached to other materials, or described imprecisely. So the yard identifies and grades it. Downstream buyers want usable specifications, not random piles. So the yard separates, cuts, bales, shreds, or otherwise prepares the material when those steps make economic sense. The material is heavy and expensive to move, so the yard consolidates shipments, manages routes, and chooses buyers with freight in mind. Some inputs contain fluids, refrigerants, batteries, or other hazards, so the yard applies acceptance rules, depollution, storage, training, and documentation. Transactions can require seller records and defensible intake procedures, so the yard builds systems around the scale, not just piles behind it. And the finished scrap has to reach mills, foundries, smelters, refiners, processors, or other consumers. So the yard creates access to commodity markets that many small upstream suppliers do not have on their own. That is the service hidden inside the spread. The spread then has to survive everything that can go wrong: buying too high, misgrading a load, discovering contamination, processing material that did not need processing, running expensive equipment below useful throughput, breaking a critical machine, holding inventory too long while the market falls, driving too far for marginal feedstock, shipping to a buyer whose higher price disappears after freight, depending too heavily on one source or one outlet, failing to build required environmental or transaction controls into normal operations. None of those problems changes the fact that the metal is valuable. They change whether the operator captures any of that value. This is why a yard can look stronger as its economics become weaker. Inventory grows, so the property looks full. More trucks arrive, so the scale looks busy. Machines run longer, so the facility looks productive. Revenue can rise because more material is moving. But if purchase prices are too aggressive, inventory turns too slowly, processing adds less value than it costs, freight is poorly controlled, or downstream options are weak, activity can disguise deterioration. A scrap operator has to resist the temptation to measure the business by tonnage alone. Tonnage tells you how much material moved. It does not tell you whether the spread survived. The same is true of the commodity price. A rising market can make inventory look more valuable, but it does not automatically prove the yard bought correctly or operated efficiently. A falling market can pressure spreads, but it does not make every operator equally vulnerable. The yard's decisions determine how much exposure it carries into that movement. This is why the phrase "profit per ton" can be so misleading in scrap. 1 ton can contain different metals, different grades, different contamination, different processing needs, different travel distances, and different timing exposure. 2 yards can buy similar-looking material and produce very different results because their equipment, buyers, geography, labor, and purchasing discipline are different. The only honest formula is conceptual. The yard earns a buying and selling spread, plus whatever real value it creates through processing and aggregation, multiplied by the volume it can move efficiently. Then, labor, logistics, equipment, maintenance, compliance, losses, and financing consume part of that value. What remains is not guaranteed by the commodity price. It is produced by operations. That is the final contradiction. A scrapyard can contain an enormous amount of theoretical value and still be a weak business. Because inventory is not profit, machinery is not profit, volume is not profit, revenue is not profit. The business works only when the operator repeatedly converts unwanted, inconsistent, inconvenient physical material into standardized commodity inventory without surrendering the spread along the way. The metal already has value. The business exists because turning that theoretical value into usable value is difficult, and that difficulty is exactly what the scrap operator is being paid to solve.